Hi everyone, my name is Anvita Bansal, and the problem that we are going to discuss today is missing number in an array. I hope you all can see my screen. Okay, so moving on to missing number in array, you can find it from SDE sheet as we always do. Okay, so the problem says that you are given an array of size n minus 1 such that it contains distinct integers in the range of 1 to n. Okay, so you're given an array in which all the integers are 1 to n. You need to find there must be one element which is missing, which is that element. That's what you need to return in this problem. Okay. So I'll be discussing two approaches for this problem that you can use to solve this one. So let's see how we can do. I hope you have understood the question. If not, don't worry, we'll come back to it. Fine. So let's write the problem here. You are given an array which contains all the integers from 1 to n except one integer, right? For example, 1, 2, 5 would be integers like 1, 2, 3, 4, and 5, right? But basically, you will be given an array which will contain 1, 2, let's say there is 3, let's say there is 5. Now, you have to consider that this is the what is the length of your array. Here the length of your array, let's say n is 4. So ideally this must be containing elements from 1 to n plus 1, right? That is 1 to 5, and you have to find which element is missing from this array from starting from 1 to 5. So we know that we want to return 4 in this case. So how will you solve this problem? See, the catch in this problem is, first method that I'm going to discuss is that all of you must have studied about sum of numbers starting from 1 to n, right? There is one formula also, n cross n plus 1 divided by 2 gives you the sum of numbers starting from 1 to n. This is the formula, right? You must have studied in arithmetic progression. This is like AP. Again, the problem that we are discussing today is very easy. It's merely based on some calculations and mathematics. Okay. Okay. So how is this formula going to help us? If we know the length of the array, we know the n, that is the last digit from 1 to n, right? We want to know n. How will you know if you know the length of your array? If your length of array is x, let's say, then your n should be x plus 1. You're understanding this thing? If the length of this array is 4, that means you must be finding a number which is missing from 1 to 5. From 1 to 5, right? That is what I want to explain here. So if you know the length is 4, that means total numbers should be 5, and out of 1 to 5 numbers, there must be one number that you want to return, which is missing from the array. Now, what is the sum of the first 5 numbers? That is 1 plus 2 plus 3 plus 4 plus 5. That can be easily solved using this formula. 5 plus 1, that is 6, divided by 2. That will be 15. Okay, you know this, right? You know this. Now, if let's say the total sum of digits from 1 to n is 15, right, given by this formula, and let's say this 15 is actually 1 plus 2 plus 3 plus 4 plus 5 is 15, then if coming to your given array, let's say this is your elements in the given array, consider this given array. Okay, I'm going to write the sum of this given array. What will be the sum of this array? 1 plus 2 plus 3 plus 5, basically. So what is this equal to? If you check, it is actually basically 15 minus 4, because only that's what is missing in the array. So the sum is basically equal to 11. What we did, we calculated the sum of your given array. we calculated the sum of integers from 1 to n. Now we know the difference in both the sums. The difference in both the sums is going to give us the number that is missing in the given array. Is this understood? Let me check if you guys can see my screen. Okay. So guys, is this understood till here? You can write in the chat. Fine. Moving on to this approach, how can we do it? Simply we can write a code which will calculate the sum from 1 to n. Finding the sum of elements is very easy. Let's say you have taken some variable total sum and you are simply adding the integers from 1 to n to it, and then you have got total sum. Then you will be iterating over your array starting from 0 till the length of your array, arr dot length, right? And then I plus plus. And then you calculate the sum of your given array, which will be equal to adding all the elements in your array, right? And then finally, when you will do t sum minus sum, when you do t sum minus sum, that's where you're going to get the answer. Then you return t sum minus sum. Okay. Now, this is the first approach that I wanted to discuss. Now, let's move to the second approach. The second approach that I want to discuss would be something like this. Okay. Coming on to the second approach that I want to discuss is again based on some mathematics, which is your bitwise operation that I'm going to discuss here, bitwise operation. So what do we mean by bitwise operation? Here, I want to introduce XOR. What is XOR? You can represent it like this, or in our coding, we will represent it with this symbol. Okay. XOR means if you take two values, let's say this is your value 0, this is your value 1, which simply represents that in binary numbers, if I draw something like this, 0, 0 and 1, 1. The bit, let's say this is, let me draw a table only. What will be the result of bitwise operations on the integers, on the binary numbers like these? Right? That's what I want to tell you. Only this is the catch here, and then you will be done with this approach as well. Let's say this is your number A, this is your number B, and this is the result of A's or B. Fine. Okay. So the property here is that if there are two values which are same, like 0, 0, then what you return is false, basically 0. Whenever you find two numbers that are different, in that case you return true. Basically, I'll not write it like this. Let me draw a chart in this way. Wait. If I were to explain this in this way, that you have two values, true, true, one is true, false, other is false, other is true, and then you have false, false again. So whenever you have same valued things, then in that case you return false. Okay, I hope you can relate with this. As we're doing, there is OR operation, there is AND operation, right? This is the OR operation that we are discussing, exclusively OR. Fine. And whenever the values are different, you return true in that case. Fine. This is about your XOR operation. Now, what in terms of integers or numbers? Let's say A is some value, and you are doing its XOR with 0, 0 doing XOR with A, then A XOR with A, 0 XOR with 0. What would you like to return in this case? See, in this case, what you want to return is basically A's XOR with 0. What will be the answer? Right? I hope you got this thing. So how are we going to use this property in our problem? Let's say 1 with 1. What it should be? It should return us 0. 1's XOR with 1 should return us 0. 2's XOR with 2 should return us 0. Right? But let's say 0's XOR with 3 should return us what? 3. Right? If this is still not clear, understand it in this way, that let's say you're given an array 1, 2, 3 in which 4 is missing, and then you have 5. And let's say we take integers all from 1 to n, that is 1, 2, 3, 4 and 5. Okay. And if I ask you to, let's say this is A, this is B, and do XOR of 2 arrays, then you will be basically doing XOR of each element with the other element, with the respective element in B. So if I'm doing so, what am I doing basically? I am doing, have a look here. If you see 1 XOR with 1, what is the answer? The answer would be similar values. When there are similar values, it will be 0, right? 2's XOR with 2, let's say, both, it should be 0. Then 3's XOR with 3 in B, again 0. Then you do not have any 4 in this A. Let's do 5 XOR with 5. This is not the, see, don't follow this kind of pattern that I'm using to calculate it's not the exact way in which the calculations would be made. I'm just telling you that by the end of doing XOR operations, what are we going to get? Okay, it does need not to, what I mean to tell you is that don't understand this thing in this way, that first one is getting its operation of XOR with 1, then 2 is getting its operation of XOR with 2. It's not going to be in that continuity. Okay. Finally, what I want to explain you is, then we have got 5's also, 5 corresponding to B, and its XOR will also be 0. Now there is 4 left. Okay. And till now, the corresponding XORs that we have got of A and B is basically 0. If I do its XOR with the remaining element in B, that is 4. When we have two different values, 0's XOR with some value A should give us 4. So the idea behind this thing is, when you do XOR operation on two kinds of arrays or two set of elements, such that one contains elements from 1 to n and one contains element from 1 to n, except some value x that we want to find, right? So if you do its XOR with all the elements in this particular set of elements, then you will be left with each equal element will be canceling it themselves out, right? These will cancel them, XOR of them will become 0, and in the end what we will be left with is 0's XOR with the element that we are trying to find, basically, because that's answer will be that element itself. I hope you have understood this thing. I'll try to write this thing again for you. So this second approach, in this second method of doing XOR operation, the idea behind this is making use of what? Let's say you have this pool of elements which has elements from 1, 2, 3, 4, 5, and you have this set of elements which is doing its XOR from 1, 2, 3 and 5, in which 4 is missing. So you know that in XOR, equal elements will cancel out, because that's the property of XOR, cancel out and return 0. So if you check all the equal elements 1, 2, 3, 1, 2, 3, and 5, all these elements will be cancelled. And what will be left in the resultant XOR? You will be left with 0 here. You will be left with 0 here. And 0, 0 XOR with 4, 0 of these elements, and then XOR of 4 wouldn't matter enough. Anyway, you'll be left with 4 to make the XOR of, to do the XOR operation with the 0 of this set of elements. So 4's XOR with some 0 would give us 4 only, be it 4, 5 or anything. XOR with 0 will give us that element itself. This is based on this property. So I hope this is understood. All zeros XOR with some element is again 0. So two approaches we have discussed. First is take sum of all elements, total sum, and then take the sum of all the elements in the array. So the missing element can be found using tsum minus sum of all the elements in your array. Second approach is bitwise operation using XOR. I hope now you have understood these two approaches. Let's move to the problem and solve it. Fine. So if we move to this solution part, I'm going to take two methods. First method, which I discussed, that we are going to discuss. So let's take int total sum. T sum is 0, right? Then total sum is sum from elements I equal to, for I equal to int I equal to 1, starting from element 1 to n, right? We want to find the sum of all the elements from 1 to n. Ideally, that can be given by n into n plus 1 by 2. So you don't even need to iterate like this, because you know the formula. That's the AP formula. We will use AP formula, which is T sum equals to n multiplied with n plus 1 divided by 2. Okay. Now you define sum equals to 0, which will be the sum of all the elements of the array. Int I0 less than T. I is less than n, you should write, or I less than array dot length, you should write. In this case, you will see that n is not equal to, let me write this point also, because see, these are very minute observations in this problem. Sometimes you tend to ignore this and you end up with index out of bounds kind of error. That's why I'm telling you this beforehand. So n is not equal to array dot length here. Hope this point is clear to you, because array dot length would be some x, right? And the n is basically from, it is corresponding to the last value of integer starting from 1 to n. So here if you see, n is 5, but the total elements in array is 4. N is 10, but the total elements in array would be 9. If you see 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the reason we are using like this. I plus plus sum plus equal to array I. And what do you want to return as answer? That is T sum minus sum. The logic you know. Okay, let's discuss the second approach. I hope this is clear to you all. Moving on to second approach. This is the second method. That is using XOR operations. XOR. Okay, so let's define some. In XOR cases, we are doing XOR of elements from 1 to n and XOR of elements present in the array. So let's store this XOR value in some new variable. So int a equal to, let's say it is 1. Because what I'm doing is, let me also tell you, first write this for int. Now I have already taken element 1 from 1 to n. So I'll start my iteration from 2 and it will go till last value, that is n, and then I plus plus. Here I'm taking the XOR of all the elements from 1 to n. So initial value that I'm going to do XOR will be a, that is I have assigned with 1 already. So a should store A's XOR with, XOR is represented like this when you code in the program, you represent it like this. It's XOR with I, that is I would be the next element. A is initially 1, 1 XOR with 2, now that will be stored in A. Now it's XOR with 3, now it's XOR with 4, then 5. Let's say n is 5. So you have in A you have got the XOR of all the elements from 1, 2, 3, 4, 5. I'll iterate it again. I'll dry run it for you if this is still not clear. Now let's take another element in B is equals to, and that will be pointing to the first element in your array. Now iterate over the entire length of your array. I can write it in this way also. Int x belonging to array, right? And then you calculate XOR of all the elements. B equals to B XOR of x. Okay. And since what I'm doing is I'm taking array 0, so let's iterate from index 1 of your array. Int I equals to 1. I is less than array dot length I plus plus. B is B XOR with I. Yeah, array of I. Okay. So this is what you have done, XOR of all the elements present in your array. Okay. Now what? Now XOR of what we have gotten from A with what we will get from B, we will do return XOR of both these values and return. Let's check. That is all about this problem. If you have any doubt, you can ask me in the chat. I hope you have understood the logic and concept behind the two methods. Mostly what people tend to do is we try to solve it using that approach, n into n plus 1 by 2 arithmetic progression formula. We know that's the simplest one, and that's the intuitive ones also, if you try to think of it at once. But I'd really recommend that you go through the entire video and also try to understand the second method, only for the sake of understanding how bitwise operations are working, right? This is mathematics, and this is also tricky. So it is much better when you try to solve using a better method. It's just my suggestion. So if you have any doubt, you can ask me. Most of the videos that you will check for this problem are being discussed or solved using that first method that I told you, but I discussed the second method only because so that you can also understand that bitwise operations, how they are performing on the elements and how it can be utilized in this particular problem, right? So that was all about today's lecture. I hope you have understood this. So if you have any doubt, you can write in the chat, or I'll see you all tomorrow in the next lecture. Fine, then I'll wrap this up. Thank you, everyone. Bye. See you tomorrow at 8 p.m.